Good day, this is Danife Oliveros, and I will be presenting chapters 1 to 6 of Computer Systems and Organization for the subject CMSC 203 for Sir Gulshan Vasan. Unit 1 is Introduction to Computer Organization. Its Module 1 is Representation of Information, and computers run a set of instructions called programs that basically manipulate data. Manipulating data means applying operations on the data, and the most common are arithmetic and logic, which is different from what we use. Binary systems are what computers use to represent data, while humans use decimal system. And so conversion from one base system to another is needed to instruct what operations are needed. Bits, bytes, words, addresses, and values. Data and programs are represented by sequences of binary digits or bits in the computer. The memory consists of a large number of storage cells. Each cell is capable of storing one binary digit called a bit. A bit is a distinction between two possible states. Example, 0 or 1, high or low, off or on, and etc. So one bit can only use this to represent two different values, 0 or 1. Increasing these to 2 bits will allow you to represent 4 different values, 0, 0, 0, 1, 1, 0, and 1, 1. Bits can be grouped into 8 bits known as byte, and 16, 32, or 64 known as word. Data entered is stored into a specific memory address, which is located in fixed length memory locations that make up the whole computer memory, where data are kept and can be used at a later time until it is needed. Number systems. Computers use a different number system. As I have mentioned a while ago, binary system, however, is long for large numbers, and so it is usually converted to hexadecimal, base 16 used as shorthand. And the other conversion systems will be decimal to binary, binary to decimal, decimal to octal, octal to decimal, decimal to hexadecimal, hexadecimal to decimal, binary to octal, binary to hexadecimal, hexadecimal to binary, octal to hexadecimal, and hexadecimal to octal. Representation of integers, real numbers, characters, and programs. Representation of integers denotes the use of complements. Two forms of these are 1's complement and 2's complement, used to represent negative integer and using a negative sign to signal it. Real numbers, however, are represented using coefficient and exponent, which is then done a normalization process. As a character set is popularly used to represent characters. ASCII code defines 128 characters, 32 of which are control characters used to give concrete messages for execution. These ASCII codes are then improved by IBM, which stretched the codes to 255 fixed characters. Programs are a set of instructions, codes inputting this to the memory of the computer for easier access. We'll now move on to Module 2, which is the Introduction to Digital Electronics and Boolean Algebra. Module 2 is focused on the hardware aspect of the computer and how the electronic circuits are used to process the representations of information. A beat is represented by a voltage in wire, and series of this may be acceptable in one state or logic level, and another non-overlapping may be acceptable to another. Two of the very known are combinational logic and sequential logic. Combinational logic is a circuit that concerns itself only on its inputs and not how the information is stored. It is built up from logic gates that perform logical manipulations, types of which are inverter and or the exclusive and or gates. Sequential logic, however, depends on the inputs and the information stored in the circuit. Types are clock, flip-flop register, counter, and shift register. The operations of all these circuits depend whether a signal is executed or not. Analysis of whether the circuit created the necessary high logic level is needed and is called Boolean algebra. Postulates, theorems, and laws make up the Boolean algebra and results to simplified logic expressions or logic circuits. And Module 3 is Computer Systems Organization. All of this make up to the parts of computer, which is the main topic of Module 3. The central processing unit is the brain of the computer as it controls and performs logical and arithmetical operations for all of the functions of the computer. Its three major components are arithmetic logic unit, register set, and control unit. The arithmetic logic unit performs the arithmetical, logical, and shift operations. Register sets hold specific functions for processors, continuous flow. The control unit, in its name, controls the machine cycle, namely fetching from the memory the next instruction, decoding, and executing the instruction currently fetched. The next major part of the computer are memories. Memory is where the programs and data are stored in numbers of cells. Types of memories are random access memory and read-only memory. Random access memory is a memory directly accessible for a read and write operation. Read-only memory, however, stores the data permanently and is written on its manufacture process. These two types of memory may take a while to be accessed, thus a memory cache is placed for faster processing of data. There are also secondary data storage, just namely USB flash drive, magnetic disks, optical memories, magnetic tapes, and magnetic drums. USB flash drive, according to Techopedia.com, is a device used for data storage that includes a flash memory and an integrated universal serial bus interface. Magnetic disks are the ones that has recordable surface in it, which is divided into tracks. This is readable through disk drive that contains special purpose computer code controller. Optical memories have much higher recording density than conventional magnetic media. Magnetic tapes and magnetic drums are secondary storages that are obsolete now, but to familiarize them, magnetic tape is similar to the home tape recorder, and magnetic drums are cylinders big as a hand that has its information written magnetically as well. Input or output system are the devices we use to communicate with a computer. Input having means to communicate the process we want with computer, and the output system where the computer shows us the direct response it was programmed to. Types of this are switches and lights, video displays, cursor tracking, devices, and printers. And for the Unit 2, Assembly Language Programming, it starts off with Module 4, Essentials of Assembly Language Programming. Assembly language programming have been the de facto standard in the microcomputer platform. Its CPU is composed of the arithmetic and logic unit, control unit, some general registers, several special purpose registers and control, and status flags. The ALU acts as the machine's brain. It is responsible for the arithmetic operations. Also, it is capable of performing relational comparisons. Control unit is composed of bus unit, instruction unit, and execution unit, which coordinates the operations of the active parts of the CPU. Registers are used to store values when writing assembly language programs. Other things taken in consideration for assembly language are memory map, coding format, instructions, operands, addressing modes, comments, source code layout, procedure specification directive, and assembly control directive and directive. For Module 5, Assembly Language Programming Constructs, this comprises of the sequence, selection, forced jump, if then else statement, compound conditions, case iteration, for loop, while do loop, and repeat until loop. Module 6, Subroutines or Procedures. Module 6 talked about the subroutines, parameter passing, schemes, parameter passing using memory variables, local variables, functions, and return values and recursion. Thank you very much, and you do have a great day.